Okay, let's continue to discuss the tidyverse. So we briefly talked about what is the concept of tidyverse, why it has been developed, and why it's going to be quite common in our data analysis, and also what is the logic why we have to use tidyverse in the modern data analysis. So this is the workflow we normally use for the data analysis. So we get a data from somewhere from the experiment or collaboration, then you transform into the tidy format, then you do the visualization and set up the model, which to look at statistical evaluation or interpretation. Then once you get that, then you generate something for communication or some outcomes, right? But in reality, you have to repeat this cycle many times to get a better outcome for your communication. So all of these cycles are enabled by tidyverse system, and it has to be many iterations. So you have to come up with some automation system by programming language, right? So there was brief motivation about tidyverse. And this is sort of basic packages you normally use for the tidyverse system. So from the import system to tidy and transformation, visualization, and model. And we're probably going to spend lots of time in learning the package deployer for transformation and ggplot for the visualization. These two tools are sort of the essential, the grounding format for your learning. And other tools like read or tidy or broom thing, this is also we're going to use in this course as well. Okay, so we spend lots of time about what is the tidy data, right? So I mean, we call tidy data, so that means that there must be a untidy data as well. So we focus on the two different data format. We contrast to each other. So one format is like a data frame models we use in a tutorial, and another data set is like this matrix, which is two-dimensional matrix and including rows for the countries and columns for the each year information. And this is sort of very human readable format we normally use for data analysis, but this is not tidy data type. The tidy data type is like these three columns and long list of rows, right? And this is sort of the similar format we see in a models data frame as well. So in a short word, the tidy data means that the long format, right? So long format is including, less numbers of columns and that column numbers into categorization. So each column has the categories or group information, and that information can complicate information by combining columns to each other, right? So this is totally opposite patterns we see in this non-tidy data format, which is we call wide data format, right? So this is the wider the shapes than this format. So this is the long format and this is the wide format. So this is one of the things we can mostly think about the importing data in your experiments or your collaboration. So one of the things you might find useful is we're going to transform this wide format data into the long format data. So there was one question appeared in our Slack channel. Someone asked about how we convert wide format into the long format or vice versa, right? So these conversions we're going to do many times in our data analysis, not just in this course, probably throughout your career. So we're going to exercise that, wide to long transformation. But I mean, if you're curious at this moment and find that questions and try it by yourself. Okay. So using the tidyverse, the first thing we can do is the manipulation. So one of the things you're going to do regularly in the tidyverse exercise is using the filter function to subset some rows or some columns, right? So tidyverse has very specific function name to do subsetting. So if you want to subset rows, then you use the filter. Or if you want to subset the columns, then you use select, right? So this is a bit different from the knife R function. So let's see how these things are different. So let's try library ds-labs. And then we're going to get the data models, right? So let's see, I want to subset the rows which are south for region. Okay, so that case you do models equal, sorry, region equal south. Then you have to put comma here, right? Because when you subset something, the before the column, it represents the condition for rows, and after comma is the condition for column, right? So that case, you're going to subset only south, right? So this is how we subset rows from R9 function, right? But if you want to use tidyverse, let's put tidyverse first. And then what you can do, let's zoom in. What you can do is do filter, then models, then you type this. Okay, so how we do that? So you put the filter here, and you put data frame here, and you put the condition here. So condition we used in naivar function is like this, but tidyverse you can only put the column name and your variable to use for subset, right? So you don't have to put models on here, right? So why these things can be done? The reason is that tidyverse itself, it contains that information. So this dot means that this data frame. So it basically omit this part within tidyverse function. So you don't have to use this. You can just put the column name and subset it. And if you type it, then we can get the same result as you've seen here, right? And one of other interesting point is you do filtering in this way, but actually in a tidyverse usage, we're normally not going to use this fashion. So how can you do that? You do models, and you use this percentage symbol with the arrow and percentage. We call this is pipe. We're going to cover that in a later slides. Then if you pipe that data frame into this function, it's going to do the same thing. So how can this be possible? So it's basically when you pipe data frame into the filter, it's basically we're going to throw this data frame into this function. So this data frame going to be automatically recognized by the first argument in this function, right? So you don't have to type models here. It's basically seen as this, and it's omitted like this way, right? So you don't have to put data frame as you're doing here, right? And this is one of very important features using tidyverse. And if you use tidyverse, that means that you're going to write your program, you're going to write your script in this way. So this is critical things you have to exercise and you have to remember. From now on, you're going to write down all of your codes in this way. So using the pipe and put the function and you get an output, right? And why we have to use pipe, and we're going to cover in soon. Okay, so let's read the filter, the command line. So we have two filter function in our package within this workspace. One is the state and the other is the dplyr, right? So as you can see here, if you want to know about the filter function, I press the F1 here. Then your R Studio set, you have two filter definition in your workspace. So one is by dplyr, the other is the states, right? So if you haven't loaded Tidyverse package in this workspace, then you only get this function. But it's actually me. I imported the Tidyverse library on here. So my workspace has the filter function from the dplyr. This dplyr is one of the package under the Tidyverse ecosystem, right? So then which filter function I use for now? So I use this filter function from dplyr because this is the lately imported in my workspace. So my workspace has this filter function for me, right? So if I click this, then it has a menu. Then this filter function from dplyr, one of the Tidyverse package. So you might find a bit confusing because I sometimes use filter function is from the Tidyverse, but it's actually from the dplyr. So which means that, dplyr is part of Tidyverse package. So it's basically the same things, right? So this is like a situation saying, I see movie character Hulk, and that's from the Avengers, right? And if someone is too strict, then he might argue that Hulk is from the Hulk, the movie Hulk, right? Is that correct? I haven't seen Avengers, but anyway, so Hulk is one of the members in Avengers. I at least I know that. So so that's in the umbrella system, right? So filter function from the dplyr is from the Tidyverse. So it's under the umbrella of Tidyverse. So if I mentioned that the filter is Tidyverse function, that's from the dplyr and also from the Tidyverse as well. Okay, so all the Tidyverse functions is basically taking the data frame at the first argument, right? So argument means that you specify some function and you put something onto the function. So argument is like the place you can set up, you can define some variables to do functions, right? So all of the Tidyverse the comment taking the data frame or the data at the first argument as a first argument, and it states as a point data, right? So that means that the point means that it can be from the previous pipe, right? So if you don't specify this and you specify pipe, that will be okay because this pipe will source the data frame into this function. This is not just for the filter. This is universal for other Tidyverse functions. So if you use the Tidyverse command from now on, then that means that you're going to pipe in the data frame to the next the next place, which are the functions, right? So that was the how we read the Tidyverse manual. So let's say we don't set up the pipe before the filter. How this will behave? It's going to be nothing because there's no the data frame or the source data specified in this function. So you have to set up the pipe onto here, right? Okay, so that was it. And also, if you want to set up the new data frame from this tidyverse language, then you can type in here and you can execute. Then you're going to get the new data frame only contain the source information in a row, right? Okay, so let's try in a different way. So I want to get only population and total columns from the models. So if you want to subset that information, then you can use the index, column index, right? So here is row, here is row. I won't subset anything about the rows, and I subset only columns, right? So we know that the population total is the third and fourth position. Then you can do type here. Okay, so many, so we can only display first few lines, right? Okay, let's do again. And this way, right? But in reality, we don't know what columns in, I mean, the column numbers on a column name. So, I mean, this is quite tricky. So, if you want to do in a tidyverse way, then you can do you can use this. We use the select, right? Okay, so select, and you type the population. And we're going to pause here. And you just type POPU, then just pause, just stop there. Then you will see pop up here, because the tidyverse letting you that the data frame comes from this pipe, and that will give you the column name from this data frame, because this is like this situation. So you do models and you $sign here, then you type POPU, then stop there. Then you can see population column from here, right? So you don't have to worry about remembering the column names. Okay, so models, select population. Okay, and then you type comma and you type total. Then see, then you can say the population and total column here, right? So you basically do the select and column name separate by comma, right? This is one way. And then we can do in different ways. We type colon here. That means that we're going to subset from here to here, right? I want to subset first few lines. Okay, so that will work as well. And why this is helpful? Because I want to, let's say, I want to subset from region to total. Then in the case we do region and total, and we get the as well, right? Or the column select has the interesting characteristic. So let's assume that you want to subset the column, but you want to reorder the column. So I want to subset the population at the first position, and I want to subset the state at the next. Then you type population and state. Then type. Then it's going to be reorder the columns as well, right? So select function, it's again like a filter. This is one of the key things you're going to use many, many times in your programming language. So you have to remember how we use. And select function also do different ways. So let's say, oh, I don't like this population column name. I want to get very short name for this column. So let's say pop. Then you can just do equal sign here. I want to select the population, but it we're going to define as a pop. Then you type here. Then now you see that the column name is changed, right? So this is another powerful things we're going to use, select. Okay, so that was about the filter and select, and we're going to exercise more and more when you do other tutorials. And another functions you're going to use many times for the tidyverse is the mutate, right? So this is adding a new column to the data frame, right? So what that means, so when you calculate, let's say, when you calculate the new total information divide by 100 scale, then you define like this way, right? Total 2, and you put arrow or equal, whatever. Then you define like this. Oops, what happened? Total, right? Then we're going to see total 2 on here, right? So this is how we define new column in a data frame. But now what we can do is, if you use the tidyverse, then you use the function name mutate, right? Then you define the new column name here, and the things you're going to add from the existing columns like this. Oops, this is too much. Let's see a few of them. Then now you see that total 2 has the total divided by 100. But this is already defined, so we're going to try another one. Total 3. Okay, so let's do the same thing, right? So this is the the one way you can define the new column, but it's always not taking the calculation. You can define whatever you want. So say hello here. Then you want to put all hello to the total 3 column. Then you can also do in this way, right? So this is the one way we use the mutate for set up the new column, right? Okay, so why we have to use mutate? Because mutate is again also very common functions you're going to use for the data analysis, but also for visualization. So if you, let's say if you do mutate many times within your code, it's way more tidy than just to our naive way, right? So I don't know how these things will be perceived at this stage, because the students mostly learning the tidyverse just a few days. So it's just, I mean, it's not easy to glimpse what the tidyverse give a advantage, but we're going to through the tutorial set with more complicated situation. Then you will see an advantage taking the tidyverse into your programming. So let's keep these words for later. Okay, so that was about the thing, and filter is basically the same connection, and select as well. And the pipe. Okay, so pipe is a beauty of using tidyverse. So this is such a central things we're going to take a huge benefit from using tidyverse, right? So pipe is basically the logical process from certain tasks. So you have many different tasks in your program. So let's say if you write up the program, this is basically following some logic. So let's say like this. This is too tiny thing, so let's put on here. So if you write up a code, right? So I mean, for now, if you do tutorial or if you do assignment, your coding, your programming is just a 1 or 2 lines. So quite, simple things. But in reality, you're going to write down very long lines of code to process your data. So first one is you import the data and you tidy up and you do transformation. And that is the step, let's say step 1. Then you do transformation again, and step 2, transformation again, step 3, and then you do the visualization, right? So this is like 6 different stages for the your data process. But I mean, this is quite, the short way. I mean, compared to what we normally do in our, daily coding. But anyway, this is at least you have the 6 different, the coding. So if you just use, non-tidyverse way, you do like, read the limit, like the file, and you load the data, or in your case, you load the data like models, right? And then you do some tidy up things. Then you transformation something, like you do total 2 models, total divide by 100, and sort of similar things again, and then you do plot, blah blah blah, right? So I mean, this looks quite simple, because I mean, this is just a dummy example, but at least you have like 6 different lines to process it, right? But if you use the tidyverse system, then you do like this. So you have the data, then you do have pipe, and you have step 1 function, and pipe step 2 function, and pipe step 3 functions, and step 4 functions, and step 5 functions, right? So you basically use the sort of one big chunk of process, so you don't have to lose your point during the programming, and you can get much simpler way to get a data process. So let's think about the one way I wrote the code last time. What would be good? So okay, so this will be one of the examples. So I mean, this is quite complicated, but let's look at this. So this is the cancer data I'm working on now, and I wrote the code. Say I want to read the data first, and we source the data into the filter. I want to filter some, the mutation by the detection confidence. Then I mutate new column. Then I relocate the column name into different column orders. So this is a very simple one, the tidyverse pipe example. But if you want to do in a naive R function, you have to double up the codes for your writing, right? And this is again the same true for other examples. This is again, I use the tidyverse system for my backbone, and this is as well. And all of the code I used in these examples as well. So this script, I calculate the differences between the tumor and the normal sample. And this is one of the shortest comment I use for my analysis. This is like 400 and something columns, right? But if you don't use the tidyverse system, and if you want to write up the same codes to do the same aim, then you will at least double up the codes or triplet up the codes, and that will be like 1,000 lines. So using the tidyverse or not, that will change lots of things for your programming. And one of the key things in this project is the using the pipe functions or not, right? So pipe is, by definition, we can perform a series of operations. That's good word, right? So we're going to do numerous steps to do something, right? And so this code series, right? And the operation is basically processing the programming language, right? So in that case, we use the pipe function, and we make a coherent workflow from between these process, right? Okay, and also this pipe is normally doing the way from the left side to right side, right? I mean, you can do the opposite way, but I mean, this is not really, the typically doing in programming, so you don't have to remember that. It's mostly working a left way. So you set up the data frame and you process that into different function, and that will take a different operation, and you will get the output out of these lines. Okay, so there was the pipe issue. What I miss? Okay, so that was about it, and we're going to see more examples from tutorial sets. Okay, so one of the things we use many times is the summarize. So summarize is literally you're going to summarize your data with a certain standard or certain rules, right? So what is the summarize? So I want to get the mean value out of my observation. I want to get the median value out of my observation, or whatever the mathematical or statistical values, right? So let's say the our tutorial said we had a height data frame, and this height information we get a the height values from the students, and that values by different, you know, the whatever the male and female, they have different heights. And what about the females median height or mean or max heights? All of that information we can use the summarize function to do that, right? So this is one example for the tidyverse way. So go away. You have to get height information first. Okay, so you pipe in height into the filter function and you get a female first. We have to look at this first. Head heights. Okay, then you summarize the median, mean, and maximum value, right? So see, it's all filter the female students, and we get a height median value that must be inches, right? And that is the mean and the max, right? And that's also true for the male students as well, right? So we get a values as well. So if we don't use the tidyverse way, you have to do like this: height, sex, female, right? And you get a height. Oops. Great. And then you calculate the median. Okay. And then you calculate the mean. And you calculate the max, right? But this results returned as a numbers, right? Not a data frame format, as you see here. So how can you make this data frame information? You have to do in this way: data frame median. Oops. Great. Mean, comma, max. Mean, max. Okay, so you get a quite similar data frame format. Oh, sorry. It has to be the same name. Maximum, minimum. Okay, so you get a same results as you use the tidyverse way. So let's see. This is the tidyverse way. Oops. Tidyverse way. R naive function way, which is non-tidyverse way. How we do that? Oops. Go away. Go away. Okay, so which one do you like? I prefer the Tidyverse way because it's quite readable, and it's basically the same 3 lines comment, but less characters, and also you see the structure of the code. But non-Tidyverse way, I mean, this is okay, but a bit of texty, right? And also, you kind of see the structure easily because you have to come up with this first, then your eye is going to move on this, and your eye is going to move on this, and then your eye is going to move this way and that way, right? And you have to repeat this 1, 2, 3, right? So, I mean, this is not very effective, right? So this is one examples why we have to use tidyverse and pipe, right? Tidyverse way is much simpler to representation. Okay, so that was about the summarize, and I want to get more more structured way for the height calculation. So we can calculate the math using the summarize function, but we add up the groups, right? So in sex column, we have male and female, right? So we have 2 binary system, and you want to get a information by group. So you're not gonna just calculate female. We also calculate males as well. So how can we do that? By tidyverse. Then we can do in this, right? So we have height, and we set up the group, and we do the summarize. Then the word calculate like this. So what is the group by? So if there's a column with factors or characters with you can say as a factor, then you basically set up the group, right? So you set up the group by sex here. Then if you execute, then you will see that the groups appeared on here, right? So this is the data frame, but this is the table format. I'm going to cover this table data frame again, but table is basically same as data frame, but it's more advanced way, because when you see the height, like in naked way, you can see like this. Ooh, it's long, and I start from here. So this is the data frame's shape, and this is the table data frame. Table data frame, it's more enhanced, it's more advanced system, so it's not speeding everything because it's clever, right? So it automatically showing that there are thousands more lines in your data set, and it recap what's included in these columns, right? So you don't have to complicatedly calculating each of them. It's already have in this type in this system. But table data frame and data frame itself, they basically functioning the same way, so you don't have to worry about it. This is more like a representation way. So in that purpose, the table data frame has many advantage than the data frame, right? Okay, so once you set up the group by, then it has group. But if you just use the table, right? Let's actually underscore. Let's see that it has the table data frame and columns as we've seen before, but you might notice the differences, right? What's the differences? This is group by, and this is not group by. So group by one has, oops. Oh, sorry, that has to be sex on here. Okay, so it's groups, sex column, and it has the 2 factors, right? But if you just the table, then there is no group information by these sex columns, right? So it's just a not group by data frame, right? So these 2 differences. Okay, so let's say if you calculate that information, then that will give you female, male, summarize. But if you omit that information, you can just comment. So you don't have to worry about that. Then let's see. Then it will has the average and standard deviation without group information, right? So that's the differences. Okay, so this group by function also one of the key things you're going to use every day, right? Because all the information we have the many layers within the data set, in a biological data set as well. So group by is not the things you have to remember in your code exercise. Okay, so let's think about different ways. So let's say, how would you do this task by non-tidyverse way? So without tidyverse, how can we do that? So how can we do that? You have to do like this. So you calculate the female data frame first. Female first and male. So male here. And then R bind. Okay. Oh, damn it. Comma here, right? How can I know that quickly? Because I spent 10 years to do these things, right? Oops, what we miss? We miss male and females. So how can you fix that? The first. This is not the median. This is average, right? So average. And this is mean. Come on, mean, average, standard deviation, standard deviation, standard deviation, standard deviation. And what was the sex? Female. And here, and this is male. Okay, so we get the same things as we see in the table information, right? Unless it's the differences between the data frame and tables, right? So which one is much easier to read and much easier to communication with others, right? But not just by yourself, right? So this is the tidyverse way, and this is the non-tidyverse way. I mean, all of you probably pick up this for better representation, right? Unless you're super complicated person, right? So writing code, writing programming is not just to keep you in a complex system. This is like you want to communicate by your outcome, but also communicate by your code as well. So you have to write down the code simplified way. Then you can work with others in a company, in a research group, in your career, right? So programming is not done by like a self-oriented word, right? Communication and also the teamwork is the key thing, even in a programming world as well. So that's why we had to come up with simplified version, and your code has to be readable, has to be read by others as well, right? So in terms of the readability, this is much better choice than this one. So this is another way why we use tidyverse in our programming. Okay, so that was it. And tidyverse also can sort the data by the numeric values. So this is same as the naive function. You can use the range function. This is basically same as order function in your program. And I mean, arrange, sometimes you use it, but I mean, it's good to know how to sort the data. And also, if your sorting can be done by multiple columns. So this called nested sorting. So you can put one column and the other column, and you arrange by these two, right? So you sort the region first, and you sort the rate second, right? Okay, so that was about the nested sorting. And also you can subset few functions out of your data, right? So you can get the top end function. So you get a top end function like, I want to get the top rate, model rate, top 10. Then in that case, you pipe in the model's data frame. Then you use the top end function like in here. Then you set up which columns you're going to use and how many top values you're going to use. So you put the 10 on here, right? So this is another things you use many times in your Tidyverse system. And also more specifically, when you do the gene ontology analysis in your genomic or your transcriptomic data set, this top end function is one of your guy you're going to use many times, and we come up with later in a tutorial set. Okay, so what about the Tidyverse? So Tidyverse is the advanced data frame, as I explained just before. So it has the better display representation. It has a enhanced function for the subsetting and also group functions as well. So you might want to read it further in the textbook as well. And Tidyverse system has the dot operation. So that operation is basically take the data frame or the previous object into the next place of the pipe, right? So you do the filter in this way, as I explained before, but you can basically put the dot and you set up the the data frame with the pipe before this, and it will automatically give you the data frame into this position as dot, right? So in the same logic, when you process filter in here, then filtered data frame going to be the next position, and that position, this mutate column also require data frame, right? So that data frame is coming from here, right? So that one is also put as a dot in here, but it's again omitted, right? So you don't have to worry about that. So what they mean? So let's look at here. So we filter models by this, right? So in a Tidyverse system, it has dot in here, and this dot represent the data frame before the pipe, right? But it's normally omitted, right? So once you run here, and then this model data frame filtered by this condition, right? And then once it's filtered, then it will pipe into the next operation. The next operation will be the data frame from the previous pipe, right? So here's the question. So you have dot in here and dot in here. So let's say this dot is the first one, and this is the second dot, right? This is the second dot, and this is the first dot. And this is the second dot. Okay, so the question is, this first dot and second dot, they basically representing the data frame. So the dot class is the data frame. So the question is, this first dot and second dots are the same data frame or not, right? So you have, if you can answer that question, you understand the Tidyverse correctly, right? Okay, so the answer is this first dot and second dot is the different, right? So first dot is this data frame, and the second dot in here is the data frame filter this information from the models, right? So the dots in here and here, they recorded the same way, but they are different data frame. You have to remember, you have to get the point. I mean, if you're not clear about that, then it will be in the channel, right? Or how you can test that. So let's look at this. You're going this further. You're going this one first. And then you're going to this next, right? Oh, sorry. A0 should be mothers, right? So A0, how many lines is the 51? And A1 only 17 lines because it only has the south. And A2, you add a new column. So it's the 17, same, but you add a new columns here, right? So each dot, so this A2 information going to be here, right? So this each dot, they've shown it the same way, but they are different data frame. You have to remember that function. Okay, so that was about the dot information. Okay, so what we can do further is the do function. So do function is one of the common things we use in a tidyverse way. Where are we? But it has to be with the tutorial. So I mean, let's continue this one in the in the next class. I mean, this is one of my favorite things to, operate the tidyverse way. But I mean, this is not easy without the example. So let's do it with the SN2 example. Okay, another information is the per package. This is the the similar functions as we used as apply, which is you apply function across many rows or across many columns. But this per package, they will provide you tidyverse way, and you do the many functions operation in a one time with the tidyverse way. But to be honest, the per package or the many operation at the same time, we call this is in a computational way, we call the parallel programming. To be honest, I don't use the parallel programming using R because R is super slow at this purpose. But this textbook give you very easy examples using the per package. So I mean, it's okay to go, but if you are if you're going to the intermediate levels of your programming for the biological data analysis, in most situations you're not going to choose R for your analysis. So in other words, the most of the data set you're going to handle in your early career stage is totally okay with R. And R can do everything for your, at least like a graduate level programming, at least for the biological science. But if you're super, serious about, I want to get a really big data in my career, that case, you have to move on to sort of big data platform rather than just R programming. So, I mean, long story short, it's okay to read about the part package and have it on your own hands. It's fine, but the part package, frankly, it's not going to be used many times in your R career. Okay, so how can we use the part package? So the concept is that when you do programming, you are going to set up the functions many times in your coding. I mean, this is universal for R or Python. As you see in chapter 3 exercise, let's say you have compute SN functions like this, and you're going to repeat this function operation many and many times. So here example is you operate 1 to 25, so you operate 25 times. So that case, you can type that, you can type like this: compute SN1, compute SN2, compute SN3, compute SN4, and whatever, blah, 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 and you type 25. So, this is too, boring, right? So you don't have to do this. So what you can do is you can set up the vectors containing 1 to 25, right? So this n has 1 to 25, right? Like this. Then you use the supply function, which means that you apply the functions many times to these functions, right? Okay, we have to set up this first. Then you apply this. So you do Sn values apply by this from 1 to 25, right? And your per package, you can use in different ways. So you do map function. So map is the mapping to these vectors to function. Then you get information like this, right? It's basically same way as applied, but it will return list and here return numeric. That case you have to map and double. That's it. That's another name of the numbers, right? So if you want to apply the same function many times on your R, then you can use either sapply map or mapdbl functions from the per. And what I keep saying, why this is quite universal when you do programming, because R has the vectorizer system. So there's not many chance to get a parallel computing for your programming. So you don't really reckon, okay, I have to use it, right? So there are no many situations like this. And also apply function is just great. So this is one of the great things you can have it from the R9 function. So I mean, I'm totally okay with apply. And also if you are really want to process the big data set, then you might want to find other, the large scale data set rather than just this R or the tidyverse functions. So that's my note. Okay, so that was it. And case in between, you can read about that. So that's all about the very brief introduction about tidyverse. And of course, tidyverse, you have to expose to the exercise many times. So we're going to through the examples we get from the SN2A next time. And then we're going to follow up the topics like data import and the ggplot, so you can prepare your tutorial sets and assignments and portfolios as well. So please have this information as well, and also be advanced for your exercise so you can come up with the questions that will expand your learning quickly. So that was one of my advice. Okay, that's all about, and hopefully you have good week start, and see you on next class.